Hello, I'm Christina. So here we are asked to graph a function by hand. We're going to do this by checking for intercepts, vertical asymptotes, and slant asymptotes, which will help us put all the pieces together. Let's start by looking for those intercepts. To find an intercept, we want to set either x or y equal to 0 and solve for the remaining variable. So let's start by setting x equal to 0. When I do that, remember anytime I see f of x, that's interchangeable with saying y. So we'll write y is equal to 0 to the third power over 6 minus 0 squared, which just becomes 0. What that tells me is that when x equals 0, y equals 0. So that is one of my intercepts. And that actually works out really well. I don't even need to set y equal to 0 and solve because I've gotten this as my intercept. It means that both the x and y intercept are this point. So I can go ahead and graph that point. I have found my x and y intercepts. Next, we want to check for vertical asymptotes. So for vertical asymptotes, I'm looking at for what value of x would I find 0 in the denominator. So I'll go ahead and set my denominator equal to 0. 6 minus x squared equal to 0. And now I'm simply solving for x. I'll subtract 6 from both sides, divide both sides by a -1 to make those signs easier for me, and then I'll simply take the square root of both sides. I get x is equal to plus or minus the square root of 6. Now, because I'm graphing this by hand, I'm going to go ahead and put the square root of 6 into my calculator so that I can get it as a decimal, which will be easier for me to graph. So I do that, I find that it is approximately positive minus 2.449. Great. So what that tells me is that I'm going to have 2 vertical asymptotes at those spaces on my graph. So I can come over to my graph. So I'm going to estimate that's about 2.4 to say it's about there. Wonderful. And then on the other side, -1, -2, about here. Okay. Now I'm ready to go ahead and check for my slant asymptote. Now, to figure out my slant asymptote, I need to go ahead and do some long division. I'm going to take my original function and do that division. So now I'm going to just reorder my denominator because this will help me stay more organized and clear as I'm doing this long division. I ask myself, how many times does negative x squared fit into x to the third? And I get a negative x. I go ahead and do my multiplication. That does give me x to the third. I need to multiply the negative x with a positive 6 for negative 6x. I go ahead and subtract those signs change. I get 6x. So now this would be a fractional component. Looks like this. Our remainder was 6x, and then we put that over the divisor. So 6 minus x squared. Now for the purposes of determining my slant asymptote, I actually only care about this piece. I don't have to worry about this fractional part, and that's because it winds up being negligible. So I only really care that my slant asymptote is going to be this line y equals negative x. Now I'm ready to go ahead and graph that. If I ever get confused or need help graphing lines, I recommend making a quick table to help you figure those out. This one's pretty straightforward. I'm going to plug in a couple points for myself to help me make that line as straight as possible. And then I'm going to extend this one a little further. Okay, and at this point, I'm ready to go ahead and fill in my actual function. So I'm going to follow the work that I've done. I see I've got this little peak here. I'm never going to actually touch that asymptote. I'm going to get close, and same within this direction. I'm kind of following the line, but I should never actually touch it. I can do the same on both ends. So here, I'm getting closer and closer and closer, never actually touching it. Closer, 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 never actually touching it. And then we also need to fill in this piece. And then we cross through here. Great. And then if I wanted to triple check my work, I could go ahead and throw in some values of x to confirm that we have indeed done it right, which we have. And that is how you do this problem.